Okay, so we're going to look at some examples of factoring polynomials now. So we first need to know what factoring means. Okay, so here's what factoring means. It means to break up a number into parts that multiply to give you back that number. So as a simple example, if I take the number 12, I know that I can break that down into 3 times 4. Okay, 3 times 4 multiplies to 12. So I would say that 3 and 4 are factors of 12, right? And the process of breaking that down is called factoring. Okay, so we're going to look at this, but we're going to do it with slightly more complicated problems. But we're going to see that there's actually a lot of different types of factoring. And we're going to start off with one called factoring out a monomial. So last example, we looked at multiplying a monomial into an expression. And we said if I had a situation like this, then I could just multiply the 3 in, and I would get the answer 3x plus 9. Alright, so now we're going to do this backwards, and I'm going to give you 3x plus 9, and my question is going to be, well, what were the two factors that gave me 3x plus 9? So we're going to go backwards and undo this process. Okay? So let's start off with a simple example. Okay? And we're going to use the instructions at the top that say, if you'd like to factor, find the GCF, the greatest common factor, of all of the polynomial terms. So we take a look at this example, 10x plus 15. Well, it looks like if I'm looking at the factors, the terms, 10x and 15, that the only common factor that they share besides 1 is the factor 5, and that would actually be the largest one. So I'm going to say the GCF of these two terms is 5. Okay? And so now the process becomes, what is the other factor? What did I multiply 5 by to get 10x plus 15? Right? What did I distribute into? Okay? So I'm going to say 5 times what gave me 10x, and that's what's going to be in this spot. Well, to get a 10 from a 5 using multiplication, I need to multiply it by 2. So I'd actually have to have 2x here, because 5 times 2x is 10x. And I can do the same thing with the second term and say 5 times what gave me the 15? Well, the answer is it has to be 5 times 3. Right, so I'm going to say that 5 and 2x plus 3 are the two factors that when I multiplied them together gave me 10x plus 15. And this is what factoring is. I broke up an expression, 10x plus 15, into two parts. And if we were to check, 5 times 2x is 10x, 5 times 3 is 15, these numbers do multiply and give me 10x plus 15 back. Right? So let's look at another example that has a few more terms and also has a few variables involved. Okay? So in this next example, we have 3 terms now instead of 2. So we're going to have to look at all 3 terms, 5, 25, and 45, and say what is the greatest number that they all have in common. So I would say this is 5 times 1, this is 5 times 5, and this is 5 times 9. It looks like they all have a 5 in common. Okay? But we also have x's in each of these expressions, which means a part of this common factor is going to be a variable as well. So I'm going to look at this and say there's an x cubed, x squared, and x. There's got to be some x here. That's common. It's a part of the common factor. The question is, well, how many do they have in common? If I were to think about x cubed, that really just means x times x times x. There's 3 of them. The middle term, there's only 2 of them. And then the last one, I only have that single x. So the question is, well, how many do they have in common? It looks like they only have 1 in common, because if I tried to say they had 2, well, this last one doesn't have 2. So I can say they really only have 1 x in common. I can't take away more than that. Right? So 5x is my common factor. So I'm going to say 5x times what gives me 5x cubed. Well, I took away one of the 3 x's up here. Right? That's the one that's on the outside. So I still have 2 left, and those ones are going to show up on the inside. I have an x squared. Right? So there's, if I check, 5x times x squared gives me 5x cubed. And I'm just going to continue this process. I need to figure out how do I turn 5x into the middle term 25x squared. Well, 5 times 5 will give me the 25, so I need there to be a 5 here. And to get the x squared back, I have 1 on the outside, which means of these two, the other one is on the inside. And then on the last term, I need to turn 5x into 45x. Well, it looks like I just need to multiply that by 9, right? 5x times 9 is going to give me the 45x. So I'm going to say these two numbers, 5x and x squared plus 5x plus 9, are the two factors of that expression. Okay. One more example, just to hit this home. Okay. So again, I'm looking at this one. I see 4, negative 24, and 8. They all have a 4 factor in common. This is 4 times 1, 4 times 6, 4 times 2. So I'm going to say they have a 4 in common. And again, if I'm looking at this like it's a pile of x's, I see there's 5 of them. This one has a pile of 3. This one has a pile of 2. I can't take more than 2 away because I run out at 2. Okay? So I can say this has a common factor of 4x squared. In order to get 4x to the 5th back, well, again, I took 2 of the x's away. I still have 3 of them remaining, so I'm going to definitely have to have that x cubed. Right? So it's 1 just to get the 4. Right? So just regular old x cubed. Okay? In order to get a 24 back, well, I'd have to do 4 times 6. And I have 3 x's when I started. I took 2 of them away. They're on the outside, which means only 1's left. Okay, and then the last term, it looks like I need to multiply this 4 times a 2 to get the 8 back, so it's plus 2. And I don't have any x's. I had 2 of them on the outside. There was only 2 of them that I needed, so I don't need to include any more here. I'm going to close it up, and I'm done.